It's time to build the crank disc. I'm going to build it per Tolley's Great Drawings out of a piece of 1 1/8 inch diameter aluminum. It's going to be a 1/4 inch wide. It'll have a 3/16 inch reamed hole for the main shaft, and it'll have a I forgot, 1/8 inch, I believe, hole for the crank pin. So the first thing I'm going to do is face off the end, maybe skim it right here to get a nice shiny look, and then I will center drill and step drill at number 43, and then drill at number 13, which is 0.182, and then I'll ream it 0.1875, 3/16. What to do with the remote control? There it is. I'm going to turn you off. I'm going to face the end of this piece of aluminum stock off. I'll have to face this entire chamfered blue section off, which is about 1/8 of an inch. Wasted material as far as I'm concerned. 1/8 of an inch, 1/8 of an inch. All right, I'm going to turn this piece of aluminum at 369 SFM, so it probably won't be much talking going on, but this is not going to be a sophisticated operation. I'm just going to face it off. That speed was the feed was too slow. Got a nice finish for what I did, but I'm going to speed it way up. I was turning or feeding at 0.00046, and I'm going to speed it up to 0.00162. So quite a bit faster, 4 times faster. We'll see what the finish looks like. Really got it in gear. Okay, I think I finally got it in gear. Looks like it. Well, the finish is just great, and even turning it or feeding at 0.00162. So I'll bring you back when I'm ready to do something else. I believe this will be the last cut facing. I'm going to continue feeding at a fast rate. There we go. Gonna break the edge with a file. Now I'm gonna go cart the file. I've skimmed off a little shiny part there for cosmetic reasons. Now I'm ready to ream the hole for the main shaft. I'm going to center drill it and then step drill it with a number 43, and then I'm going to number 13, and then I'll go to the 3/16 inch reamer. Don't need much of a hole for number 43. That's why there's not much of a hole there. I've never used a straight flute drill bit before. This is a replacement machine screw length bit that I bought from McMaster. So we'll see how it works. A little too much there, wasn't it? Sure it's doing anything. Yeah, I don't have it tight enough. Let's try this again. Works a lot better. Fed the chips straight back along those flutes. I wonder if that's big enough to act as a... You know, I think I'm going to step drill it. I'm going to center drill that a little bit larger for the number 13. I'll go a little deeper and give my reamer plenty of room to work. Alright, I'm using a Whitman and Barnes Hercules. High-speed steel, straight shank, straight flute chucking reamer. You know, this thing may be older than I am. Yeah, I don't know, it may not be that old. A little air in the situation. I'm turning at 64 SFM for the reamer. Oh, looks exceptional. Now to part it off. I'm going to use this hand ground parting grooving tool I made. It's about it's about 0.144 wide. I haven't measured. I haven't mic'd it recently. It's really wide, and I get beat up because it's too wide and it wastes stock, but it sure works well. And I like to give her a few strokes with a stone before I use it every time. Oh, that feels good. All right, we're going to part this 1.125 inch aluminum disc from the stock. I'm turning at what amounts to 34 SFM for parting. It's 115 RPM on my lathe and at this diameter. And I'm feeding at 0.00069 inches per revolution. I'm told that I'm cutting way too slow with a parting tool for aluminum, but this works for me. So maybe experience will teach me to do it a little faster. Oh, by the way, this is at 0.00069 inches per revolution feed. That's the fastest I've ever cut it. I've never cut it this fast, so maybe it's too fast. I don't know. We'll find out. And I won't make you sit through the entire boring process. I haven't touched it yet. Closed any time now. Lubricants touching, there we go. process, it's a party process. Getting close. I don't know how close. I'm always wrong. That's pretty close, but well, that's a pretty nice cut. Just left a little chip there. This almost doesn't need to be faced. This makes me happy. I'm going to center drill, then drill a number 43 hole for a 440 set screw to hold this crank disc onto the main shaft. I will relieve the number 43 thread after I drill it to some diameter larger so the set screw will pass through it, and then I will only thread the last 1/8 of an inch or so. One of the smartest things I ever bought was this Albrecht keyless chuck. This Kurt Weiss's right up there with it, maybe above it. Drop the wrench. Notice how I'm slowly getting there, pecking there on through. I'll tap it without moving the setup, other than lowering the knee. I'm going to go down 210 thousandths with this number 42 drill. I think that'll allow me to get the 440 set screw in there. If not, I'll make it bigger later. I've already zeroed my quill DRO. So here we go. Now I'll tap at 440. I've already gone in a few turns. I'm being very careful. I broke a 440 tap here a while back. So I broke it in aluminum, so I'm being extra careful. I'm not exactly sure, but I think I'm cutting threads in the larger clearance drill size, so I may not have made that big enough. The whole point is of that clearance drill is so I don't have to tap all the way through this length that I really don't need it, because the set screw is only 1/8 of an inch long. So I'll finish tapping this. Okay, I can already see threads in the clearance hole, so that didn't work out as planned. It needed to be larger. I'm not going to make it any larger, because the whole idea was to have it such that I didn't have to tap that distance. But now that I have. Yep, there it appears, so we're good to go. I need to put a hole in this disc for the crank pin. This since the stroke on this engine is going to be 3/4 of an inch, that means the throw is going to be 3/8 of an inch. So I need to measure from here to here, 3/8 of an inch. Well, how do I do that? I've got to have this hole underneath the spindle. There may be several ways to do it, but God invented gauge pins, and so that's what I'm going to use. Kind of lightly chuck it up there, and then I'm just going to move the table until that gauge pin, which is a 0.187 minus, I guess I should have used a 0.188 minus, maybe. Anyway, I'm going to move the table to the 2 line up, and then that's where I'll be. I'll be good to go. There we go. Now I'll lock it, see if it still goes in. Yep. Now I'll just move it 0.375 inch in the Y direction. I suppose if we want to get technical, I'm going to move it minus 3.75 inches in the Y direction. Okay, there's 200, now I need to go 175. And there. We go. And that is where the crank pin hole will be drilled and reamed. I need a I need a 1/8 inch hole here, located rather offset from the center 0.375 inches, which I've already done. And offset it in the y-axis for the crank pin. So I'm going to center drill it, then I'm going to drill it number 31, which is a 0.120 inch, and then I'll ream it an 1/8 inch. This is the wrong reamer. So we'll center drill it, then drill it, then I'll find the right reamer. I've been having good luck drilling with a number 31 for an 1/8 inch reamed hole rather than a whatever bit is just under an 1/8 inch, because it's a 0.1, the bit under an 1/8 inch is 0.109 and this is 0.120, and the less you can remove with a reamer, the better. Now I'll go back to the tool chest and look for a 1/8 inch reamer. As I mentioned earlier, we're going to ream this crank disc hole 0.125, and here's my 0.125 reamer, which I did not have in the box, as I said. 3 days have passed since I mentioned we were going to do that. On day 1, I ordered this reamer and a couple others from McMaster, and on day 3 I received it. It's pretty good service. I use McMaster car quite a bit. So we're going to ream it. I've set RPM such that it'll produce a 64 FM speed for me. Shoot a little juice to it. And that's all there is to that. The crank pin hole's been reamed to 0.125, and I've got a 0.125 inch dowel pin that ought to be a pretty light press fit into there. See if I can get her started and then use my press, otherwise known as Kurt Weist. Go in there. There we go. That looks pretty good. So there's the crank disc. Here's where we are today. The valve works well. No, it doesn't seem to have any hang-ups. See. I think you'll be able to see the valve moving up and down there. The crank disc is built, obviously the main shaft is either got to be shortened, or actually I think I'll extend the main shaft out this side to give me room to put a pulley on if I should desire to run something. I don't know what it'd be. Maybe a a generator like Tubal Cain recently showed on his horizontal spool valve engine that he just finished building. The piston's built, and I believe the piston rod that hasn't been built yet, that's the next thing and almost the last thing. Got to build the head. I believe it's going to connect correctly without rubbing on the crank disc. If not, then I will have to turn the main bearing down just a tiny bit, not much. Looks good though. So that's where we are. Can you see the piston in there? Check it out. There's the piston. It turned out to be nice. It may be too long. If it is, I'll shorten it up a bit. My plan had been to keep the wrist pin of the piston inside the cylinder wall while it's operating. I don't know if that plan's going to work out. Unless either that plan may not work out, or I'll have to build a new piston. However, I don't know how important it is to keep that wrist pin in there if the wrist pin is inserted in such a way as to not come out. I'm going to use this little piece of brass as the connecting rod. Don't know how long it's got to be yet, and of course I've got to clean it up and shape it. It's going to be, according to Tolley's drawings, 0.437 on one end and 0.25 on the other end, but that's all cosmetic. I'll approximate that on the belt sander, and then I'll start fitting it to the crank pin and the piston. I just separated it with this. Oops, wrong way. Just separated it from a larger piece of scrap with my 2 3/4 inch, maybe 2.5 inch. Let's see, slitting saw. 2 3/4 inch slitting saw, turning at 196 SFM, and I power fed it. Worked fine. I sliced me off a piece of brass, as I showed you earlier. Now I'm going to poke a hole in it. I've kind of determined by feel right there, and I will I'll drill a .120 hole, a number 31 drill bit, and then I'll ream that to .125. Just so you'll know, there's a hole directly underneath where in this piece of aluminum sacrificial plate where I'm going to drill. Of course, I forgot to get the reamer out. There's no way to get to it, I don't think, without moving the camera. I'm turning it fast as this mill will go, which is 2950 RPM. And for those of you that are interested, that means I'm drilling this brass at 92 SFM. Now to get the reamer out. It's one of my new ones. Oops, lower the table. I'll get you back in focus, or get the view recorrected here after I get the reamer and the chuck. Oh, it ain't too bad right there, is it? Go a little bit better. All right. That's all there is to that. I know this looks pretty rough, and it is pretty rough. I'm going to hand radius the upper end, and I'll hand radius the lower end, and I'll hand taper it. But I wanted the wrist pin hole in it first. Now the wrist pin's a loose fit in a, well, don't mean real loose, but it's an easy fit in the piston. And since it's 0.125 inch in diameter, and this whole reamed hole is 0.125, it's going to be a press fit in there, which is what I want. It's not going to be much of a press fit, but it'll be good enough. I believe it will hold the connecting rod in place for me. Oh heck, I didn't even have to use my hammer. That kind of disappoints me. So it really wasn't much of a press fit at all. The piston is 0.8 something in diameter, and the wrist pin is 3/4 inches, so that worked out real well. And next is to assemble this on the engine and figure out where the hole for the bottom end goes. I've positioned the piston at what I want to be top dead center, with it's about half the steam port showing. Trying to position this light so you'll get a glimpse of the steam port. And I'm going to mark the connecting rod where at the length where the crank pin is at this position, at this piston position, and hope that turns out the way that I envisioned. Alright, it's time to drill a hole for it. By the way, Tolley has a vastly improved connecting rod to crank pin mechanism that I'm not going to employ on this engine right now. I may employ it after I finish the engine. It's up and running. This video series is finally posted. Well, it's all posted now except for the current videos. I just haven't made them public. But after all that's done, I may come back to this engine and employ Tolley's bushing mechanism for the crank pin. It looks interesting. I think I can do that. I believe I'll have to rebuild the crank disc, or at least have a larger crank pin. But I've got to study what he sent in the email drawings, which I'll post. Well, you'll have seen them by now. So, back to drilling reaming. I've located the position for the crank pin hole, and clank shoes all clamped and marked and ready to rock and roll. I'm going to center drill it, then drill it, and then ream it 0.125. I'm going to drill it, of course, 0.120. Being careful to make sure my chuck misses the clamp, using that short center drill. See if I can get the drill bit in there. I did. I'll have to lower the table for the reamer. Lower the table now, I guess. Good picture of my head, I imagine. Actually, a poor picture of my head, because any picture of it would be a poor picture. Alrighty then. The camera's still positioned well enough. That's all there was to that. Now I'll take it to the belt sander or something and radius it like I did the piston end. Well, the assembly process. Now, Mr. Pete kind of cheated and bent this out a bit, but mine, I don't think I want to bend it. What I think I'll do is chop the crank pin off about right there. Fortunately, I've got a crank pin chopper off tool here, but it'll be ugly, so I'll do that off camera. Here we are. A little bit stiff. I can work that out. Timing looks about right. Oh, the main bearing's come loose. I'll tighten that up. Oh yeah, once I tighten the main bearing up, it runs a lot better. As I said, the timing looks about right. You know, all about all that's left is to build a square head for this baby. This makes me happy.